one thing I wanted to talk about before we get started this morning is that we've been out in classrooms, many of you, and we are just seeing such amazing, amazing things happening with you and your kids. And I just wanted to thank you guys for being so open and willing to let us come in and see what's going on. We're seeing number talks, we're seeing starts, we're seeing Choose Three Ways and Think, Pair, Share, and all kinds of just incredible work out there. I'm just so humbled to be in the room with all of you that are just doing such profound, amazing things with kids. So thank you for that. So let's start for tonight. Tonight we're going to start with number talks, and we're going to talk about what number sense is. And then we're going to dive into choosing tasks. And then we're going to do a little breakout rooms about 5:15. Okay? So without further ado, Deb.
So I'm going to show you a Wordle. How many people know what a Wordle is? How many people think you're going to find out in just about 1 second? All right. That's a Wordle. The really cool part is you can just input, it's a website that does this, you can input a paragraph, a whole paper, and it counts the number of times a word is used and makes it larger if it's used mostest. That's my bestest English. So would you please look for 3 words in there that resonate with you, and then I'm going to have you, after you find 3 words, turn and talk to your neighbor about 2 things. 1, the 3 words that resonated with you. So you need to listen also to your neighbor's 3 words. And then the second thing you guys are going to talk about is, what does number sense mean? Keep your hand up, or raise it if it's not up, if you said one of the same words that your neighbor did. Does it resonate? And then raise a hand if you and your neighbor had 6 different words that resonated with each other. Interesting. Okay. Let's get 2 thoughts. Somebody out there, and I'm just going to run over to you with the microphone. What does number sense mean to you? 2 thoughts. You could say something your neighbor said or something that you said. Thanks for raising a hand.
I like the words see, reason, and connections.
How many people think those are some nice words for talking about what number sense means? 2 of us. 3 of us. How many people heard the question? Oh, not everybody did. Okay, maybe that's the problem. So how many people would like her to repeat those 3 words so you can decide if you agree or disagree? All right, here we go.
See, reason, and connections.
Now how many people think those have something to do with number sense? All right, okay. One more person want to share either your words or what you think about what the meaning of number sense is for our second person. This is my wait time. There we
go. My 3 words were understanding numbers together.
How many people think those words even go together? Nice, all right. Okay, so a few of the things we've been doing have been trying to get kids to make sense, even maybe build some number sense. Number talks is one of those. So we're going to do a couple number talks tonight. And I want you to be thinking about the choice of tasks that you use for number talks and what you're reinforcing when you do number talks, because I think a really cool thing to do with number talks is to build number sense. So we're going to do a number talk, and I'm going to give you some temporary amnesia. You ready? You forgot what 6 times 9 is. You forgot what 6 times 9 is. You're not allowed to spit out, what's the number? 6 times 9, you're not allowed to spit out. What is the right answer? Yeah, you don't know that. Okay? So come up with a different way to figure out what 6 times 9 is. You can't do there is no standard procedure. I just took it away from you. See? I just took it away. You forgot it. You don't know. So think quietly to yourself. Give me a thumb up when you have a strategy for figuring out 6 times 9 when you forgot what it is, that it's 54. You forgot. But come up with another way. Thumbs up when you come up with another way. Nice job quietly thinking. I didn't even have to give them directions because they already know how to do the process. Yeah. Another way to get 6 times 9. So I got about, 4/5 of you. People are probably thinking, all right. Would you please share with somebody at your table? I'm going to do this differently because I want to give more people a chance to share since we have so many of us. I'm doing this differently than I would in a classroom. Share at your table how you did it. So I got some people ready with whiteboards. Kathy's going to be first to record. Is there somebody out there that will share either the strategy they heard from a neighbor or their own strategy for how you could get what 6 times 9 is if you forgot that it was 54? Anybody willing to share a strategy? I'm going to go over here to this young lady. So Kathy's going to record what you said.
All of us agreed over here that even if we forgot for real, we would go 6 times 10, 60, and then subtract 6, so we could remember.
How many people heard that? How many people also did that? Sweet. Did you catch that, Kathy? Of course, we gave her the pen that was writing with invisible ink. All right, so she'll get that one down. Did anybody have a different way or another way? All right. Oh, there is one hand over. Oh, there's 2 hands. I see 2 hands. Interesting. I wonder if these 2 people have the same way. So here comes another way. You're going to get this one, Cammie? All right.
You do 9 times 5, which is a friendly number with 5, and then add 9.
How many people think that also works? So if you do those things, do you have some sense about what multiplication means? You can't make those adjustments unless you know that 6 times 9 means I'm either doing 6 9s or 9 6s, right? And then you can make some adjustments to friendly numbers and then adjust back, right? Either go 10 times 6 or 5 times 9, and then make the adjustments. All right, so I would argue that one of the reasons you would do number talks is to build some number sense that you don't actually have to have them do standard algorithms. Okay, one more. Ready? Okay. Was there a question out there? Okay. Oh, I'm sorry. One more number talk. You can clear your mind. I should be more specific. All right. Once again, no standard procedures. So here's what I would hope I don't want to see. I don't do this when I'm in the grocery store actually trying to figure out if I have enough money. I don't want to see the error algorithm. Line up your numbers vertically, put the little time sign, draw the bar, do this, carry that one. That's not what we're trying to build, all right? I'm taking that off the table. Or if it was a subtraction problem, don't do the error algorithm, okay? Do something else. Find some other connection to be made. Build some number sense. All right, so here goes the problem. And once again, thumbs up when you have a way to do it. 29 times 30. I got one thumb up. I appreciate all the quiet thinkers out there. You guys are doing marvelously. You're sitting closer than kindergartners do, and you're doing excellent, giving everybody quiet think space. Two thumbs up. 3 thumbs up. I see some pencils going. What's up with that? You must be writing down what I'm doing. You're certainly not doing a multiplication algorithm. Did I just catch him, Cammie? All right, I hear a lot of talking. I'm guessing you guys are done. Raise a hand if you have a way to get 29 times 30. 1, 2, 3, 4, 5, 6. Wow. How many people need more time? Now I'm confused. How many people think I needed a few more hands to figure out which move I got to make? All right, so let me ask this. How many people have a way to get 29 times 30? All right, so it was just because you couldn't hear me because you were busy thinking. My bad. All right, so somebody willing to share a strategy for 29 times 30. Who's writing this time first? Joe's turn? Okay, Joe's turn is going to write first. All right, we'll go right over here.
I did 3 times 3, 3 times 3, add 2 zeros, take away 29.
Do you suppose she could say that a little faster?
No. 3 times 3.
Okay, pause. How many people know what she did next? Tell your neighbor what she did next, please. Okay, let's see if you were right. We'll let her say what she did next. She did 3 times 3 and then?
Add 2 zeros.
How many people remembered that? Is she done? Okay, I'm going to call a teacher timeout on myself. Joe, do you have it so far? Okay, good. Awesome. So I'm calling a teacher timeout on myself. In the Number Talks videos and book and formal strategy, they pretty much stay with one kid and let that child explain the whole time, and I just did something different. I just turned back to you all to start. I paused that person partway through. First off, I was so happy she said it so fast because then we couldn't catch it all at once, and I had to say the first step, and then I paused and asked her what would she do next, and you guys now are all invested in what's going on. So that might be something that we could add on to build what is going on with the rest of the class. You can decide whether that makes sense or not. Sometimes it's really good to have a kid speak the whole time. Sometimes it's good to pause and have the kids take the next step so that they're engaged too.
I have a question.
Yes.
So I didn't get 900, Joe. I don't know how you got that because I did 3 times 3 equals 9 and add 2 zeros. Plus 0 equals 9.
How many people know what Fran just did? How many people agree 0 plus 0 makes 0? How many people thinking adding 2 zeros, we're working on some specificity of language there, yes? Okay. Could if Miss Gibson was the teacher and she said that, do you suppose this person would correct her? How many people think that she would correct her? You want to correct her? Don't you love correcting Fran? You got your chance. You can correct Fran.
Move the decimal point 2 spaces to the right. I hope that's the right direction.
How many people know why she's moving a decimal point? Could somebody explain what she multiplied by in order to move a decimal point?
Not 3, I'll tell you that.
What did she actually multiply by to move the decimal point 2 spots? What are you actually doing?
Multiplying 10 by 10 by 10.
How many people agree with that? How many people think we're reinforcing the conceptual part of the procedural thing that she was doing? Yeah?
So
Go ahead, Fran.
so as the teacher, my next question would be, where did you get the 3? I don't see any 3s up there.
How many people know where she got the 3?
And I'm not putting you on the spot, but what, if we want, Debbie said no standard procedures. My other rule is you have to talk place value. You can't talk shortcut. And as a teacher, when we talk shortcut, we are supporting the shortcut learning, which I think is full of holes. And that's a cool shortcut way if you understand what you're doing. Are you getting tired, Joe? Yeah, you're up there faking it there a little bit. So we have to be real precise to say, I don't see a 3 up there. What is it? What did she multiply by? A 30. That's way different than a 3. So we just have to be real good about talking place value.
So we got the content side that Fran was dealing with. You've got at least 2 things in your head. The content side is the conceptual. Did the child actually say it conceptually? And you got the pedagogy side. Is this a chance for me to turn it back to the class and ask them a question to involve them in that person's method? So just because you don't have enough to do in your day, we thought we'd give you 2 more things. All right. So I think that's what we were going to do for number talks, and I believe that Fran's up next, but I forgot how I'm supposed to.
We are going to now get into sort of the meat of today, not that number talks were not.
That's a warm-up.
The warm-up, that's what the number talks, but we're going to start to talk about tasks. Because we are seeing clear evidence wherever we go of all of you trying out tasks with your kids. And so there's an art to picking some really good tasks. You may have picked a task where you go, I'm never going to do that again. Or you put a Post-it and you say, yes, this is a keeper. I want to do this next year. And hopefully in your book you're keeping track of ones. But we can also tweak some tasks. So we're going to talk about this. Now, is this video embedded, Cara?
Yes, and?
Yes, and?
Yep, we have it 2 ways.
Okay.
How do you want it?
No, first I'm going to do this. Okay. So we're gonna talk about these 10 principles. And these principles come from, and you will get this handout, so don't feel, oh, you have it. These 10 principles on how to pick a task. When you look at it right now, you might go, I don't know about this. But we're gonna show you a video of Dan Meyer, he'll explain why he thinks these are 10 really important things to consider when you're choosing those bigger tasks for your kids. Okay? So just really quickly kind of scan over them. If there's one you go, I have no idea what that means, don't worry. Okay, so here we go. What I'm going to do is I'm going to set this up for you a little bit. Dan Meyer is a local grad. He's a UC Davis graduate. Right now he's an associate or an assistant professor at Stanford. It's one of the A professors. And he has a blog where he just collects cool problems. He thinks about math all the time. If you thought we were bad, oh my gosh, this guy's way over the top. And so he has a blog, he has video, he has YouTube, and he was invited to one of the TEDx conferences to talk about what he's trying to do with his kids in problem solving. He's funny, he's a dynamic speaker, but he also has a lot to share with us when we consider how to set up problem solving in our classroom. So it's about 14 minutes long. And he was a teacher. Oh, yeah, well, he'll talk about it, that he's a teacher. And he's a new teacher. So that means he got kind of the assignments that nobody else wants. And he'll talk about that, too. So we want to put a little tag on Dan Meyer. He's at one end of the spectrum, of the problem-solving spectrum. And he is absolutely doing this all the time. And he, when he was in the classroom, was getting those kids that perplex you to enter into the math conversation. Okay? So he didn't start necessarily like this, but he takes problems right out of his book and he goes ahead and he tweaks them. Now, I heard some questions. I heard one up here. How much time do we spend? So you can't do this every day necessarily. Your intention matters a bunch. What's your intention? How long do you spend based on that intention? And we're going to talk about that. But his intention is, 1, to get kids to think. 2, to get kids to persevere and stay with it. And then in that perseverance, to ask for the information that they think matters. That's huge. That's what thinkers do. And quite honestly, I agree with him. We want to raise a whole generation, many generations of thinkers. For those of you like me who are on their way out in less than 10 years, holy smokes, they're going to be running the world. I want problem solvers because we haven't always done such a good job. So rote procedural people don't function as well as people who can think and problem solve and not go crazy. And we're going to talk about some of the things we did today when kids can't get solution right away. Kind of fun. Okay, so here we go. We're going to go to Dan Meyer's principles. And we're going to go through the top 7 because you're going to use them today because you're going to get to look at a problem and mess with it, okay, with your colleagues. So the first one is this idea of perplexity is the goal of engagement. Human brains like to figure things out. They just do. Now, if they've been in habit of being spoon-fed, then that's just a habit that has to be broken. And that takes some time and some perseverance on the educator's part, but it can be broken. But we like to be perplexed. We like to figure things out. We like today, Jerry and I said so many times, oh, you got the noise. You got the aha. Well, how affirming is that for a kid who gets up and shares something and their colleagues go, oh, they go home skipping. They're happy about that. That makes them think that they can do it. I hope I won't trip anywhere. Okay? So this idea of we want to promote a curious state. We want to introduce a question into a student's mind that mathematics can answer. He has a whole bunch of sound bites that I really love. That mathematics, that the conversation should serve mathematics. No, what is it? Mathematics should serve the conversation, not the conversation serving mathematics. That mathematics is the voice for your intuition, the vocabulary for your intuition. So that's what we want to start with our kids. Okay? Let's look at the second one. Oh, the hook. Okay, remember how he baited the hook? With that achingly slow video, how long is it going to take to fill this up? Oh, good, that's the question we want to ask. So in your group, when we send you to mess with a problem, you got to think about how do you get your kids engaged? What's the hook? Okay? All right. I love this one. So pure math can be engaging, and we're going to talk about pure math versus applied math. Applied math, however, we shoehorn it a lot. I don't know about you if you have a shoehorn at home, but I used to watch my grandmother use a shoehorn to get her foot in a shoe that probably wasn't good for her foot. You know, it's like, I'm trying to fit this foot into this shoe that you want to go, Grandma, throw the shoe out. Look at this. Only in math problems can you buy 60 cantaloupes and no one asks what the beep is the matter with you. That's shoehorning math. That's not a real situation. Who buys 60 cantaloupes? Unless you're on some major nutritional thing. I don't know. I just
Big old
don't
melon
know.
party.
I guess so. And I ain't coming. I don't like cantaloupes. So the whole idea is that we really have to consider the reality of the problem. And let's talk about the difference between pure math and applied math. Pure math is just messing around with numbers, messing around thinking about numbers. Some of us do that all the time. Okay? So you're just dealing, like Debbie's number talks is just dealing with pure math. 29 times 30. Can you figure out a way to do that in your head? You know, Mark and I were sitting in the back talking, how about 6 times 7 and 7/8? Can you do that in your head? That's just pure math. We're just messing with numbers. Applied math is using mathematics to answer questions about the world. And if I'm 7, it might be about my world. Okay? Questions or comments on that? Is it your turn?
Almost.
You have a question?
I do.
Question?
How many people out there find it challenging to try and figure out how we're going to get our kids engaged a little bit? Yeah, so that's what we're going through, the little bit of this. Sometimes they can just get engaged about pure math. Sometimes they want a real sort of context to think about it. But either way, that's why we're together. That's why we're going to spend some time on it today to actually go, okay, what can we look in our book and how can we tweak it? So that's what we're getting to. So I think the next slide is thinking about how could you pose a question? So I'm going to give you a choice. You can see there's a visual up here. You can't even see what it is yet, and I'm hoping that you can see it when we actually play it. There's going to be a 27-second video, and I'm wondering if you'll ask yourself a question at the end of those 27 seconds. And then the next slide will be kind of a more atypical thing that we do in textbooks. It'll be a language way to pitch the question. What I want you to think about is which way makes you think of a question more, okay? So I want your teacher brain on when you do this. All right, so I'll show the 27-second video, I hope. How many people have a question in their heads? Tell your neighbor a question that you thought of. Who's willing to pose what's a question you thought of when you watched that video? What's a question you thought of? Question you thought of? I got one person that thought of a question? Really? 2, 3, it's popcorn. 4, 5, 6, 7, 8, 9. Since you're close, I'm going here.
How many pennies in the stack?
How many people thought of that? Oh, how many people thought of that question? All right, anybody got another one? You're getting abused over there because they're close.
How much money total is that?
How many people thought of that one? Any other questions?
How many layers of pennies are there?
How many people thought of that one? How many people think we could be here a while coming up with questions? Let me ask you to do this. If you were thinking about the penny question, how many pennies? Can you decide in your mind what would be the least number of pennies that you think is even possible for that stack? And what would be the maximum number that you think would be, beyond it, what are the extremes? Minimum, maximum. How many people think that's a good idea to ask those questions? All right, so I won't even make you answer those questions. Okay, that's one way to pitch a question. Dan Meyer, that guy in the video from 4 years ago, in 2013 started a Google Doc. This is one of the video clips on the Google Doc as a way to pitch a question, and he's got a whole mess of them. We'll give you the URL, but you could go check it out. But we could also look in our textbooks and take apart those skier type problems to figure out how could we pitch this question. It's in our textbooks, it's just got too much information. How could we take a little bit out to make it more like this kind of thing? All right, so here's another way oh, I don't have to sit down, I forgot, I got a clicker. Did it go? Could have done that, right? Just showed you the picture and said, how many pennies are there? I did this part. Guess as close as you can. Give an answer you know is too high, give an answer you know is too low. How many people like watching the video better to come up with their own questions? How many people can see educationally that it would get kids more invested if they come up with their own questions? All right, so that's the thing to think about when you're doing question posing. And so that was one of his principles is about how to pose a question, and this is what he's suggesting, right? So he's got that Google Doc that's a start, or we can take apart our textbooks, or we can come up with all kinds of ways. How many folks can see that this would be less language intensive if you're able to use a photograph or a video in order to pitch a question? So that might actually reduce the cognitive demand on the kids because it's less language. All right. What other, it's on there. There was a bullet, sorry.
Number 5, yeah. So I get to do 6 and 7, all right? Okay, here we go. So 6 and 7, we played around with, especially today. We've been in classrooms this week, and today, Jerry, my partner in crime, where is she? There she is. She found these pretty cool problems from Mars tasks. They're Mars tasks. Inside mathematics. And they're the problem of the month. So this principle talks about setting a low floor for entry, but a high ceiling for exit. Meaning, and we did this today, and I'll show you the problem that we did, meaning get everyone involved because they can be successful, then you ramp it up. Okay? So you don't give the tricky, hard, difficult problem first. You give something that gets them in, gets them thinking about what they're going to do, and then it becomes hard, and then you've got them. They're willing to try because they were already successful. Okay? This idea of low floor, high ceiling, of course. Okay? Then the next one is also related to this idea to use progressive disclosure to lower the extraneous load of your task. I have a signal that I used today. Stop. Okay, at one point we have to stop talking. Do you remember what his 5th principle was? Be less helpful. As teachers, we get into the profession because we are helpful. Our helpfulness is not allowing children to learn and to grapple and to struggle. We want them to struggle every day, every single day, okay?
So our helpfulness is not helpful?
Not at all. In fact, it's unhelpful, dishelpful. Dishelpful?
I don't know.
I'm not an English person. I do read, but so I can mess with it. Anyways, if you went to the Saturday seminar, Tim Kanold used this. This is an SBAC 6th grade, I believe, released item. And it talks about Sarah and her claim. You have it on the back of your paper. So talk with your neighbor right now. What might be a low floor to get in? And what information might you just hold on to, see if the kids come up with? Talk to your neighbor about this. And these 2 principles. Anybody have an idea for what might be a low floor on this? What kind of information might you not want to give? See if they come up with it. No low floor? Got a low floor for this? Yes. Oh, my friend. Good, we can redeem our friendship.
There you go. I'm not sure if it's a low enough floor, but maybe asking 2/3 times what would equal 2/3?
And the cool thing would be, you may not even have to ask that. If someone does that, you bring them up. So a student can kind of establish the low floor or the first step. Okay, that's really important. Thank you for that. Anything else? How about some information that you want kids to discover and boy, you're itching to tell them so they'll keep it forever?
I want them to discover that the fraction doesn't necessarily have to be less than 1.
And you know what? I could stand there and tell them that, or I could find a kid who's grappling with it and bring that kid up. Where will I get the longest lasting? Where will I get the connection? Probably from the kid. Yeah. Okay. So something to think about. Anything else? Okay, because we're going to let you do this. We're going to let you give this a try. Okay? So here we go. We're just dealing with the 7. Principle 8, 9, and 10 is not very awful. But remember, here are the 5 from Dan Meyer's talk. This idea, use multimedia when you can, like Debbie did. Use pictures, have kids generate their question, okay? You can kind of control the questions that get generated just by what you show them, okay? Encourage student intuition. Like, what are you thinking about this? What might be important? What do you have to consider in order to solve this? What do you need, okay? Ask the shortest question you can, okay? That leaves you out of doing all the math. I don't know about you, but I already went through the grade I taught. I don't need to do it again, right? Okay? Number 4, let the students build the problem. But that means we have to be really comfortable with them not getting it right away. That sitcom-sized problem solving. Okay? Maybe a problem comes back. Maybe you do it one day, it shows up again tomorrow because we haven't quite completed it. And my favorite one, be less helpful. Okay? Anybody, raise your hand if you have a problem with that. Teachers really have a problem with that. We want to help you all the way so you stop thinking.
I was going to say, I know I catch myself grabbing their pencil.
Oh, that's a bad sign.
That was one of those things I had to come up with a new habit. Put both hands in the pocket and, okay, I'm not taking your pencil away from you and showing you how to do it.
Let's do an experiment. Point to the person right now who you think is the most tired in your classroom at the end of the day. It should not be you. You've already been in 2nd grade. You've already been in 5th grade. It shouldn't be you going home going, I'm so tired. It should be them. They should be doing all the work. Okay? That's the interesting thing. Did we have a hand? Yes.
Did you want me to get it?
No, I got it. Regina.
Yes. I have a question because I know I have been asked by my administrator to use lots of explicit, direct instruction. And what it seems to me, it seems like I'm supposed to work the problem out, show the kids exactly how to work it out, model it, and then say, okay, now you go do it, which to me seems as though I'm doing all the problem solving for the kids instead of saying, okay, here's the problem, how would you figure it out?
Okay, I think you're tapping, thank you. I think you're tapping into intention, and we're going to get into that next. So you really are a good lead-in to what we're going to talk about. Okay, so we are going to talk about that. So here we go. Ready? Yes, Debbie?
I wanted to talk a little bit about be less helpful before you went too far down the next path. So I don't think we're trying to say that, no, I'm not helping you ever.
What we are saying that. You should have been in my 6th grade.
What we're trying to do is get the kids to own it a little bit more and figure out how can you nudge them so that they are doing it, so that we are doing a little bit less of that you were describing as far as doing the whole process so that they then own it. That doesn't necessarily mean you're sitting at your desk, right, not doing anything. That's not what we're talking about. What we're trying to figure out is how do we turn the process over to them? And I might have to ask them some questions that lead them and guide them, and we have to figure that part out. And that's a shift in our role. And that's what we were meaning. So we don't mean go sit at your desk and just wait till they get it done. That's not what we mean by be less helpful.
I think one of the concerns I had before you came into my classroom and did an instruction for me, you terrified me. I panicked when you said, okay, do the lesson. And I was like, what? I'm not ready. And I told them, you can't come in. And then they walked in, they said, no, let me show you what we're going to do. This is exactly what they showed me, how to do this, how to ask the questions. And the kids were doing all the work. And they would just throw in one question. And then the kids were working. And I'm like, they're miracle workers. How do they do this? If you watch what they do, because they don't really observe your lesson, what they start doing is stepping in and showing you how to ask those questions that this guy does. Because and I've been teaching for almost 30 years. But the way they do it, it really helps. So when you get a chance to have them come into your classroom, don't panic. But invite them in because you'll really see what they're talking about. Makes sense.
Okay, your check is in the mail. Okay, so
before you, I really am just itching to address the direct instruction piece.
Yes.
So we are not, this is not instead of, this is in addition to. So you are doing that direct, and what we are talking about is that student engagement part. So if I'm pitching questions when I'm doing my instruction, part of what we're trying to help with is to figure out ways to push some of the work out onto the kids and the responsibility instead of, more like a helicopter parent. When I was in the room, I was like the helicopter teacher. I'm waiting, I'm wanting to control every single thing, right? I see some nodding. And so trying to let go of that a little bit is more what we're talking about be less helpful. So I think it's in complete alignment with what, as a district we've been saying about direct instruction, what your administrator wants, that's absolutely in line with that. It's just more about the questioning piece of it. Is that a little clearer? Okay.
That's the way we've taught forever, quite honestly. And there are other math programs out there that are saying there are struggle problems. In Go Math, you have some problems that you can make struggle problems, where you're still teaching, you're keeping fidelity to the program, but you're still teaching strategy. You still have a direct instruction portion of your lesson. This is just a think time, a problem-solving time. And when we talk about intention, you have direct reasons why you're doing it. and you're looking for things, and you're seeing, how did everything I just taught last week play out? Because it makes no sense to know procedures if you can never apply them. Okay, so this is the application part big time. Okay, so don't be afraid. Don't be afraid. The best of us do it, and I think you'll like the payoff.
So we're going to try and take those principles and apply them to our Go Math curriculum and pull those problems out of there.
Yes,
Sorry.
we are. So here we go. Now, we don't use, this is not a Go Math question that we use today, only because we're kind of a traveling show, and we don't know necessarily where people are and that kind of thing. So this was the doozy problem. If you take a look at it, it's level B. We did it in a 4th, 5th, and a 6th grade classroom today, and it talks about this wheel shop or this bike shop that's selling go-karts and bicycles, and they have 21 seats in the shop and 54 wheels, and the kiddos have to figure out how much of each do they have. Now, we did have to come to an agreement that a go-kart has 4 wheels, so we worked off that premise, which sometimes happens in problem solving. You have to agree on premises that are a little sticky. So we agreed that go-karts have 4 wheels and bicycles have 2. But this was not the first problem. The first problem that they saw, the hook, the low floor, was I have 18 wheels and the shop only makes tricycles. How many tricycles can I make? 6th graders did this. So we got them hooked. It was like so easy, it wasn't even funny. They did the problem, they shared it out, they showed a math model, not an art model, a math model, and they were able to go on to the second one. We had so many kids solving this and really sticking with it, persevering, not giving up. We used our starts like crazy. We had like 3, 4 kids get up and show starts. We were on purpose picking who showed. We wanted really basic math model pictures to maybe algorithms. We had one little kid in Mr. T's class, what's his name? Emilio, who got an answer. He's a number cruncher. He took 54 divided by 2, said there would be 27 bike wheels and 27 go-karts. Divided 27 by 2 and got 13.2. We don't know why it was 0.2 and not 0.5. And then he divided 27 by 4 and got 6.75. And he told me that he would have 6.75 go-karts and 13.2 bicycles. So I then, what do you suppose I did? I said, tell me what a 6.75 go-karts, what that looks like. He goes, well, it's really easy. You get 6 go-karts and then I would give you 75% of another one. And I said, I'm not interested. I want the full go-kart. So it was this idea that number cruncher kids are notorious for getting the right answer and notorious for when their answers are wrong, not taking a second look. So we have to, if that's all you did with your problem solving, that's enormous. So tell Emilio we talked about him in front of a bunch of teachers. That was really fun. Questions or comments yet? Because now we're going to put you in a little activity where you're going to try one on your own. Okay, pizza. This is kind of not fair to do this right before dinner. Okay, so take a look at your pizza.
And that's from Go Math.
It is a Go Math problem. So this is what I want you to think about. Uh-oh, don't start yet. It's a 4th grade problem. And just with your elbow buddies, the people who are sitting at your table, we want you to take a look at this problem, and we want to say you can tweak it in a Dan Meyer kind of way, okay? So what we want you to do is, first of all, you're the 4th grade teacher, and this is the problem coming up. What's your purpose? What's your intention? Are you teaching a strategy? Maybe you don't want to tweak the problem. Are you seeing, are they making sense of all the stuff that they've learned? And I'll tell you, there's a really important concept in this problem that if they don't make sense of it, they don't answer it correctly. So if you spoon feed it too much, and you've already talked about it, maybe you need to go back. It'll give you some feedback, some intervention ideas, okay? So first, what's your purpose? And so this is what we want you to do. With a partner, or a trio, or a 4, we want you to take this problem and tweak it, considering what's your intention. We want you to look over Dan Meyer's 7, get a hook, get them excited about it, And then discuss any math practices that are on your placemat that you want to really make sure show up in the kid solving of this problem. I'm only going to give you about 5, 6, 7 minutes. So start talking about the pizza problem. So what do you want to do with this problem? First of all, as you share out, we want to hear what your intention is. If this is the first step out of the chute, dealing with this, you will have a different intention if I've been doing this for a full week. Okay? That's what we're talking about, purpose and intention. Because we had to powwow a little bit back there. I was being a little rogue. Absolutely will you do direct instruction if you're teaching a procedure or if you're teaching a strategy. Absolutely. You say, here, I'm going to show you something. Let's try it. Now you try it. But if I need to see if they are understanding and making connection, I can't do that in a I do, you do. I have to allow them to grapple. And that's all over Go Math. We just have to identify and maybe tweak a little. So who wants to tell us how they tweaked? That sounds bad. Who wants to tell us how they edited? Miley Cyrus. Yes. I know it's a different word. I didn't fall off the turnip truck yesterday. Okay.
Actually,
wait for your audience, please.
and I've actually done this problem with my class, but what I put up is a fun-size Snickers bar and a full-size Snickers bar, and break it into the force and stuff and say, well, which one do you think I'm going to want to eat? And I'm not on a diet, and so anyway, and they just talk about it.
Okay. And that's a very important piece of information that you may decide, depending on what your intent is, to show up front, to see if you can facilitate out of the kids in the room, to show at the end. Very important, thank you. And it involves chocolate, even more important, okay? What else do you want to do to this problem? I knew you were going to raise your hand. You had that raise your hand look.
I almost didn't. Well, we were kind of wondering, do you even need to know that it's a quarter of something? Like, he has 2 pizzas, and they each have 1 piece left, so therefore they must be the same size. Because I thought, I don't want to throw anybody under the bus with me, that it seemed like the purpose is to get them to understand that not all 1/4 are equal in size. That makes sense. Does that make sense? So with that being, do you even need to put 1/4 in there? Let them figure that out on their own, and maybe even have nothing, but just verbally tell them, he's got 2 pizzas and they each have 1 slice left.
Okay. So see, then they have to decide what they have to consider. Yes.
I should just sit on my hands.
I would do more of a hands-on approach and not have any words at all. I'd give the kids a chance to pick a partner, and I'd give each group a circle of paper and a square or rectangle of paper, and I would ask them to divide each shape into equal parts, and then to see if they were able to match them up to have the same.
Okay. See, both very cool ways to change this problem, because your intention is to get kids thinking and to consider the one, the whole. I could tell you that, and I have told you that if I taught you in 5th grade a lot, but I don't know that you remembered it. But if you had to grapple with it and get up and kind of prove your point and ask questions, you would hold on to it. Anybody else? How else did you? Yes. Ooh.
Actually, I was over hearing the partners at my table that actually weren't talking to, and they said it's a very visual problem, and I would have to agree with them. In fact, when I kind of represented a model on my page, and I was like taking a look at it a little bit more, and then I realized that the pans had the same, what I want to call the same diameter and the same height, and I didn't notice that before. And so a kid who may just be like a visual learner and not really be that kid that's all great in math, they might understand that too.
Well, actually, you bring up a good point. We just heard it again today. We are getting kids to involve themselves in the lesson who have traditionally not. I mean, it happened to us today somewhere, wherever we were. Somebody told me, some little girl who never gets up, got up and explained something. Mr. T, you were telling me that. That alone is worth doing this every now and then so that kids can say, I can make sense of this too. Is there a problem? And then I've got like 2 minutes. Okay.
That's what she told me. Let's just keep going.
Well, is there, Regina?
What's your name? Elizabeth said first she would bring in a photo. And then and our question would be, which slice of pizza would you choose and why? And if you brought in 2 different pizza, one Domino's and maybe one a Chicago-style pizza, then that would change the whole dynamics of what a fourth of a pizza would mean.
Sure. Absolutely.
Is it anchovy?
Yuck.
I was thinking pepperoni.
Okay.
You like
what
it?
about this piece right here? I don't mean pizza, I mean of the question. What do you think of that? Would you keep it? Would you delete it?
I don't think it's the same principle that you're teaching about quarters can be different. This is different pieces. They're not talking about the size of the piece.
And in fact, Jerry did this with the adults in the room that are sitting back there. And some of them drew 2 models where the fourths were exactly the same. So they said, see, I told you. I said they were the same, and here's my picture to prove it. So that may be a step that's not needed because that step would come out in the argument that the child makes. Any other comments on this problem?
Oh, I got one over here.
Yes.
One of the things that we talked about is that we would start off by possibly showing an animated video and showing the pieces disappearing as part of the hook. And then also just ask the question, do you agree with Ben? Take out the whole, what is his error? We're not going to tell him there's an error. Do you agree with Ben? And then as they're arguing that, they would come up with more questions of information they wanted.
So if you just take out this sentence, what is his error? You have Ben brought some pizza to class. He says that since 1/4 of each pizza is the same, he has the same amount.
And they show that on video.
Yeah, agree or disagree with that?
It's like Pizza Monster instead
Prove
of Cookie
it.
Monster.
Okay? So you have to allow kids to grapple and think. And sometimes in our problem-solving problems, in any book and in Go Math, it gives them too much information. So we're saying train your eye so when you want this application time, you can delete some of the stuff and just pose the question and see what happens. Okay?
Anyway, as you're planning your task, have you guys all taught Chapter 9 already? Okay. There is a group over there that hasn't taught it yet that they might do different than people that have already taught it. It might be more helpful. Yeah, but you can stay where you want, but it just might be more helpful for you. You're going to be expected to give this test this week to your class and then bring it back next week just like we always do and sort them then. So as you're picking your task, keep that in mind that you have to teach it, okay?
Some more scenario if we wanted to, and maybe some scenario could be after we've determined what the picture shows, something along the lines of, we want to paint these shelves. What's a math question we could ask? And let them develop the question.
Or even we want to make these shelves. Right. And then what kind of information do we need to do that?
And how would we find how much we need? What shapes are involved in finding how much area is needed? And would we find the area the same for, hopefully they'd say that's a rectangle, and would they find that the same with the triangles? And I remember when some of my students did it, some of them did it 1, 2, 3, 4, 5, 6, 7, 8 triangles. And some said, well, just figure out that there's, it's a hole. It's a rectangle. And then you just need 4 of them dividing in half. And of course, but I'm just saying multiple. But you could generate, they could generate the ways to do it. Because some of my kids actually said, well, we figured out the whole rectangle, then we figured out this triangle, we figured out this triangle, they added them all together, then they did it for this one. And some of my kids said, well, why did you keep doing that? Once you did the first one, they look like they're all the same. And then we got
coming up with distance. Yeah, okay, so we're going to take
and they were all throwing out those answers and doing it. So somebody writing it down, because then we're all going to do it. So simple question.
Don't you think that though, before we tell them, what shapes do you see here and what can we do, that we let them come up with that? They think, tell me all you can about this picture that you can come up with. So tell me everything.
See how many different things.
Right, to come up with to solve this problem.
Someone
What do you see
might
here?
try to do the area just looking at that. You might have some students that will immediately jump to, oh, I need to find the area of the wood to build these. You might.
Okay, so if they draw it,
right,
and then we can have them, and then we give them the measurements, and then they will label.
Right. And have two starts.
Yeah, bring 2 kids up, showing that. Okay. So then, if everything's labeled, I know I'm going to have kids asking me, oh, what was that formula again? They're going to want to go straight for the formula. So how do we get them away from that? Now, you've not taught this yet necessarily.
Well, this is where I just stopped.
Oh, you did?
I mean, I'm on we did do, because we haven't talked about that we're not painting the bottom or that we're doing the lateral area.
Well, that should have come up here, though, and when we were discussing the painting of a filing cabinet, like which portions would we? So then when we're drawing, then that's something that we need to ask. What are we going to draw?
Exactly.
So that question needs to come up at that point.
That's true.
What parts are you going to draw?
Okay.
Will you draw all 6 sides, or are you going to draw 5 of them, 4 of them? What are you going to draw?
What are you going to paint?
And maybe what are you going to paint? That's right.
Right,
and maybe
exactly.
cross out that bottom flap, the bottom, so that they know we're not painting that. It would stick to the carpet. Okay.
Okay. Yeah, we don't need to paint that. But just remember that when you're painting, you don't need to paint things you don't see.
That's right.
You don't even need to pull it away from the wall.
Okay, so if they've got the measurements and they have their net, then how are we going to, do we tell them? I don't want to be too helpful. Do we tell them? Now, can you please try to find the area?
It must be in the program somewhere.
Or are we going to say surface area?
I think the next thing after we give them the measurements would be to have them apply those measurements to the drawing.
That's what I mean. They're labeling the drawing.
Okay,
Sorry,
so
mine is backwards.
Oh, okay.
Yeah. So they have to draw the net or the 3D figure.
And you want that when you say
label means this. Sorry.
Oh, okay. So label doesn't mean front, back, top,
No,
bottom,
no.
left, right.
No,
See,
that's what I do too.
See, I do
do
too.
you?
Yes.
Left, right.
Oh, I
So
could
that
do that.
It's good for them to understand that the left side's going to be the same as the right side, the top's going to be the same as the bottom, and the front is the same as the
Okay, no
back.
problem. And then we'll label afterwards with numbers.
Yeah.
Label the dimensions. Okay.
Left, right, front, back. That's what I do.
Okay.
And then top, bottom. Which we're not going to.
Right. Okay, and then you discuss that.
This problem, and there's going to be some brainiac in the class that looks at that my cost.
So when they
figure it out, then I'm done.
Then they'll have their
And that's why we want something that want to be a fraction.
You almost want to show them that
And
without
then maybe as you're going around, if you got that group that had it, then maybe, like that whole group is not getting it, they're having to write it out. Well,
Especially since there is an actual skating field trip usually at the end of the year. Yeah. That would definitely hook. The question is, are we getting them to get the objective of the lesson, or are we just getting the real life bite to get to the solution?
Well, this one it's simple enough that most kids can get it.
Because the solution may not be the objective
But
of that
if
lesson.
you change that number to 3,000
Letting them do it, and then using them, having them come up like you're saying and share it would be.
And I think for a lot of us, we're doing it as a review. So now that we're reviewing, you don't have to tell them that, but it's like, you're doing it and see what they can come up with and say, oh, now I can see how you remember what are we actually looking at. Right. Because they're going to have to come up with this all again on their own, and a lot of them aren't going to remember the whole process that they did with this.
Explain their reasoning. Why did they just find one triangle and multiply by 8? Explain why you can do that. Because and they have to say, because it says they're 14 inches.
Or if they do a rectangle, why did you do that? Why did you?
Yes.
why did you not divide by 2?
And you'll see
with a formula?
someone, someone will do a rectangle.
Oh, yeah.
Because they'll know that they're the same. I put them together based on everything back here that they were doing.
And then just have them explain it and come up and explain it. And there really wouldn't be much teacher necessary talk. All you'd be doing is having them share and explain. And you could actually at the end, I always have my kids vote. Which way do you like? And they never all were in agreement. Oh well, I understand it this way. Why? Well, because this and this. And it's fine. And it's what's interesting is later on tests, you'll see them incorporate the way they like. And I don't force them to do somebody else's way because they don't understand that. So I think it's a good problem, even though we're reviewing it. I mean, some of us are reviewing.
Yeah, and you know what, too? That before you even have them come up and share, you could even say, show 3 ways. Go back to using, or
whatever. Yeah.
That's on here too. Choose 3 ways.
Oh, choose
questioning, facilitating, another.
And if you have groups, then in your groups, make sure that you do it. That you come up with at least 2 ways. If not in 3 ways, because then they really have to show number sets.
Can't you tweak this though also so you have the students that are higher and say, okay, now we have the supports. Let's say each one of our shelves are 5 feet, whatever inches long. So now how much wood do we need for all 4 shelves?
Or ask them to come up with a question. Can you come up with another problem? Can you extend this?
See, okay.
And see what they can come up with.
And then we want them to come up with the information that they need.
Yeah. So are we going to, for those groups that are having a difficult time figuring out the distance,
well, I think at this time we're not actually asking them to come up with an actual number. It's just like, how would you solve this problem?
Just give me the answer and say, I like that. We did our math test.
Because you don't think that we should go all the way to completion? Well, because this task is actually not that great of a distance. Basically, what they're having is graphic.
I did the same.
But it's also in small proportions. Yeah, I mean, we could go through that, but initially we want them to say, so what would we need to do to tackle this problem? So we, if they immediately want what's the distance, that's all they're going to focus on. What we need to do is, selectively give them that information slowly. I think.
If they do that, like making on their whiteboard, figure out what information you need to solve.
Yeah, and I don't know that I think when they're ready, I think I would just give them the distance from San Francisco to Depo Bay as blank.
And their rate.
Yeah.
The 3 miles per hour and leave it at that.
But I think they need to noodle through what would I would do to solve this first, and they need to come up with some sort of equation. Do you guys agree with that, or what are you thinking?
Well, no, I don't want to assume that all we're going to do is ask them to come up with an equation. I want them to come up with
on their whiteboard.
Want them to come up with what they think, how long, because we didn't watch all the sound on that video. They could have said how long it takes them on there to swim. So if they give us something other than 3 miles per hour, if they give us 2.6,
because a lot of
obviously we need to watch the video ahead of time and make sure that they either don't give us a distance, so we're giving them the one of 3, or if they do, that it's a distance that is reasonable for them to be working with. Because we don't want them to be bogged down with the numbers. Same with the distance from Depo Bay from San Francisco.
So we can start with the simpler. So like she said, start with a simpler problem. So what we want them to come up with is we want them to be able to come up with a distance formula because it's something they've already done. So we want them to come up with an equation that they would use, and then say, well, let's start smaller.
Oh, good.
Okay, they travel at 3 miles an hour.
I hope so.
If they're only traveling 10 miles,
okay, perfect.
Using what you generated, how long would it take them to get there? Okay, what about 100 miles? Yeah.
Like the suite of 10, they're going to entry level.
Yeah. And then we can go, and then we can build up to, okay, well, it's 500 or 382.6 miles. So now, how long will it take them? Does that sound like what you mean? Yeah. So they actually will solve the original problem, but that won't be the only problem they solve.
Right. We should have them compare unit costs. So we're going to throw that in along with our graphing.
Right,
So
that'll work.
what did you say again about the
All right,
gas prices?
so-
That was a good one.
Oh, the
Or
gas price.
No, not the
Okay.
gas, but the
Well, we're going
price
to
of
do a Costco price, okay? So if you go to one grocery store, this will be their hook to get them in first time. If one item costs this price, then make a table showing data and then graph it. And then we think everybody we can do that because that's come at the end of chapter
Do you
9.
encourage them to make an XY chart at that time, or let them decide if they need it?
Definitely. I'm going to have them put it in a table first and then use those points to plot it. And then the second question after they've been hooked is we're going to tell them that Costco has a multi-pack of the same item at a different price. And the kids are going to put that data in a chart, and then they'll graph that too, and they will compare the different prices or the different charts and see which one's better for them to purchase.
And then you'll ask them to look at the relationship between their graphs.
Right.
And their
Exactly. So which line is steeper, which line is not. Maybe they'll notice what slope is. Maybe they'll say I want to buy the grocery store item because they only need one.
Right.
Maybe they'll say I'll get the Costco pack because I got to feed my whole family.
So that's a whole nother question.
Yeah.
We could ask them which one would they buy, and then we could get a debate going about that depending on their needs.
And it's only 2 questions, so it's not a whole lot of teacher talk.
Like that. Right on.
Yeah.